Hey guys, so welcome to today's video. We're going to be talking about basic terminologies in electrical technology. So first of all, we're going to start by kicking and telling you some definitions of some terms that are very important in this course. So we're going to start with the first term, which is electrical charge. So first of all, what is electrical charge? So we have the first terminology, which is an electrical or electric charge. Now take note. Electric charge. Take this down. Electric charge. Now, electric charge is the property of matter that causes it to experience a force when placed in an electromagnetic field. Take again. It is the property of matter that causes a body to experience a force when placed in an electromagnetic field. So take note. I told you it's a property of matter that causes a body to experience a force when placed in an electromagnetic charge. So now take note, there are two types of charges. So we have the types of charge. So one, we have positive charge. So we have positive charge, and the next one, we have negative charge. Now, positive charge, of course, we all know that is denoted by this symbol, positive charge. Okay, now take note. Protons do carry positive charge. So positive charge are protons. Why negative charge are electrons? Electrons. So take note, these are what? Protons, but these are electrons. So these are the symbol for it. Very important. So we're heading to what? So the next terminology we're going to take note of is electric current. So the next terminology is what? Electric current. Very important. So now, what is electric current? Now take note, it is the rate at which the quantity of charge moves around what? The electric circuit. It is the rate at which quantity of charges is the rate at which charge moves around the electrical circuit. So when you hear the word rate, what comes to your mind? When you hear the word rate, what comes to your mind? That means it is being calculated with respect to what? Time. So take note. So we are having electrical charge, which is measured in what? I told you earlier in our video, measured in ampere. So the symbol for electrical charge is I. So anyway, you see, sorry, electrical current, you're having I. So this is I, signifying what? Electrical current. It is the rate, when they see the rate at which a charge, so we're having charge Q. Of course, you know that this is charge. So the symbol for electric charge is Q, which is the quantity of matter. Electric charge is Q over time. So we're having this as what? The charge over the time. So this is in ampere. Very important. So this is what? Electric current. So this is the second terminology we use in this course. So now let me tell you what the conservation of electrical current states. Now it's very important you know the conservation of electric current. So now that's not a terminology. That's not a terminology, of course. It's not a terminology, but it's very important you take note of this. That's the electrical conservation of electrical charge is based on the conservation of matter, which says that for matter, they say that matter cannot be created nor destroyed, of course. Now the conservation of electrical charge is that The electric charge in a circuit is always stays constant. The electric charge in a circuit, the net electric charge in a circuit stays constant, meaning that the charge cannot be created nor destroyed. So that's the conservation of electric charge or current. Very, very important. Okay, now we're going to talk about the types of current. So the types of current, we're going to talk about types of current. So we're having types of current, types of current. Of course, there are types of current. Okay, now, so the first one, we have direct current. So we have direct current. We have alternating current. Alternating current. So first of all, let's play with this first one. We said that current is what? The rate at which charge moves around the electrical circuit. Now, direct current are current that moves in only one direction. If the current is flowing from point A to point B, it only moves from point A to point B. It does not reverse, only in one direction. That is what a direct current is. Now, an alternating current, as it says, alternates. If it's moving from a point of A to B, alternating current will move from point A to B and from B to A. That means there's what? An alternating or reverse direction. If it flows, it comes back. That's an alternating current. Okay, now let's talk about the third terminology. So we're having the third one. So this is not under the types of current. It's very, very clear. I'm going to make this very, very clear that the third one is from what? The electric under the terminologies, not the types of current. So we have the electromotive force. So we have electromotive force, also known as what? Also known as the EF. So this is the third terminology in them. So we have electromotive force. So what is electromotive force? So electromotive force is the driving force in an electrical circuit. The driving force in an electrical circuit. That's what the EMF is. Now it is measured in volt, of course. This is measured in volts, which is measured in volts. So the fourth one is the potential difference. So we have the potential difference, also known as what? PD. So we have the potential difference, also known as what? PD. So take note, the potential difference between 2 points is the work done required to move 1 coulomb of charge from one place to another. Now, let me illustrate this. So this is point A, this is point B. Potential difference between these 2 points. It's the work done, which is the work it will take to move a charge, which is Q, let's use capital letter Q, from point A to point B. The work done it will take to move the charge Q from point A to point B. That is what the potential difference is. So we have the potential difference, which is the PD, which is also measured in volts. So we're having the PD equals to what? The work done. So we're having work done over the charge. So this is W over Q. So now, also this is measured in volts. So we are saying that the volt is equal to the work done over the quantity of charge. So this is the potential difference. We say that is what? The work done in moving 1 coulomb charge from point A to point B. The fifth terminology you're going to notice is power. So we are talking about electrical power. So electrical power is the rate of work done was the rate at which work is done in an electrical circuit. So in an electrical circuit, work is done when the charge is being moved from one place to another. So power is talking about the rate, and I told you anywhere you see rate, time comes in, right? So the rate at which work is done in an electrical circuit is what? Electric power. So we're having a mathematical expression for power as what? We're having power as work done over time, which we say that P is equals to what? Work done over time, which is measured in what? Watt. So the unit for power is what? Watt. Very, very important. So now let's talk about the sixth terminology, which is energy. More of like an electrical energy. So energy is the ability to do work. So anywhere there you see um the charge is being moved from one place, and the charge is being moved or current flows, of course there's an energy, because energy is the ability for the charge to work. So energy is what? The ability to do work. So now take note. It is also known as what? The electrical input. The electrical input is more of talking like the electrical power at, it is the product of the electrical power at that time of the work. So we can say that the work done is the ability to do work. So we have energy, which is something as work done. Of course, it is measured in joules. So it is measured in joules. It's measured in joules. So we have energy signifying E, which is equals to what? The electrical input or output. So we're having the product of the power, which is the electrical input or output power, multiplied by what? The time of that work done. So power multiplied by what? Time is what? Energy. Now, so we have defined some parameters and terminologies, and we're giving you some mathematical approach to these electrical terminologies and basic electrical terminologies. We'll be able to talk about the resistance and the conductance in our next video. Thank you.